Okay, questions on that? I know some of you are still right, so I'll let you keep writing. When we name these, we will use V if there's not any other vector. So if it doesn't give you any letters, always just use V to show a vector. Okay, we'll just set that as a rule for today. Okay, let's keep moving on. So if we want to write these as a unit vector, we know that 2 is in that A slot, and 5 is, I'm sorry, we're not writing them as unit vectors, linear combinations. A is in the A slot, 2 is in the A slot, 5 is in the B slot. So if we were to write this, it would just be 2I plus 5J. That's all you have to do, okay? So you don't even have to do all those steps. I think that's kind of silly. Just go ahead and put it into your linear combination form. So here we would have negative 7I plus 3J. Okay, it's very basic, very easy. But sometimes we don't have that component form. So you have to find the component form first. And as we've been doing, that's right here. Okay, that part has not changed. So you would do x2, which is negative 5, minus x1, which is negative 9. So those will become addition. And then we'll do negative 6 minus 8. So to simplify, let's see, we have 4 comma negative 14. When you write these, it's not necessary to write a plus and negative. So when we write this into the vector form, we would say 4I, minus 14J. So if it's negative, just change that positive to a negative. So here we have to find that component form as well. So we should get 8, negative 1. Okay, check my work, make sure I get the same thing you are. We agree with 8, negative 1? Yeah. Okay, and then we put it into a linear combination. AI plus minus J. Right? Or you could say minus 1J. It doesn't matter if you put the 1 because it's implied. If you don't see a number, it's implied. Real quick. Okay. So next one, okay, is we're going to be using our unit circle. Okay, and I passed that out to you. You should have one of those. Okay, I'll show you how to use it kind of as we go. Okay, but when we have an initial point that starts at the origin, okay, and we're talking about a unit vector, that means that its terminal point falls on that unit circle. So if you look at the unit circle, the terminal points fall all along that, okay? And it doesn't necessarily have to be the degrees of the ones that show up. It could be, for example, like 97 degrees, okay? So it doesn't have to be a nice number, but sometimes it will be, and that's why we need a unit circle. So because the unit circle has those terminal points, we can write the vector as cosine theta or cosine of your angle, comma, sine theta or sine of your angle. So here's what I want to point out to you, okay? A is always the cosine. So when we look at A right here, A will always be the cosine of whatever that angle is. B will always be the sine of that angle, okay? So I'm just going to label that for you. You can label it if you want to. Okay, so cosine is always X or A. Sine is always Y or B. So then from there, if we're talking about every vector, okay, so not just unit vector, but every vector, we take that cosine and sine and we multiply it by the magnitude. That's what's happening right here. So we basically find a unit vector that goes along with that regular vector. Okay, if we want to write it as a linear combination, so instead of component form, if we want to write it in linear combination form, here's what that would look like. That's just with the i's and the j's instead of your regular component form with the arrows. Okay. So we're just gonna dive in and do these. Okay. So it says here, find the component form. So don't worry about the linear combination form, just component form of each vector with the given magnitude and direction angle. Okay. So if we look back, we're going to be using these guys right here. Okay, because they give you the magnitude and they give you the angle. So we're going to use this guy right here. So we already have the magnitude, which is 8. So our unit vector is going to be 8 times, and we're using component form, okay, cosine of 60 degrees, comma, sine of 60 degrees. Okay, so if we look, I want you to look on your unit circle, okay, and locate 60 degrees. 60 degrees is right, let me highlight it here. Okay, 60 degrees is right here. I said that the x value or the a value is always which one, cosine or sine? Cosine, right? So 1/2 is the cosine of 60 degrees. You checking with me on that? You with me? Okay. The sine of 60 degrees is square root of 3 over 2. Okay? It makes it really nice because we don't have to do all that inverse calculator work. Right? It's just going to tell us what it is. And if we did do it, we would know that 1/2 is 0.5, but square root of 3 over 2, we wouldn't know that decimal. Okay, so here it gives us a nice number. So if I go back, whoops. If I go back here, okay, we're gonna rewrite cosine 60. What was cosine 60? 1/2. So that's going to change to 1/2. What was sine of 60? Square root of 3 over 2. Now we just distribute our 8, kind of like we did yesterday, okay, and the day before. So you distribute that 8, so you get 8 times 1/2, oops, comma 8 times the square root of 3 over 2. What's half of 8? 4. Okay, now this other one's a little trickier. Okay, if we multiply 8 to a fraction, it's going to go to the numerator. We've already talked about that. So it'll be 8 square root of 3 over 2. Can I simplify that? Can 8 over 2 simplify? Yeah. Okay, so we'll leave this 4. 8 over 2 becomes 4, so we have 4 square root of 3. And that's our answer for that one. You'll get faster at these. You won't have to write all those steps in between. Okay. Those will probably end up being like 3 steps because you'll get fast at them. Okay, questions for me before we keep moving? Okay. So our next one, go ahead and write your starting formula here. So we have 20 times the cosine of 225 and then sine of 225. Okay, you're going to reference your unit circle. Sometimes these angles will be on the unit circle and sometimes they won't. The unit circle will trump your calculator. Okay, so if it's on the unit circle, I want you to use that. So we look for 220. We don't have, I'm sorry, 225. We do have 225. Okay, 225 is right here in the middle. Okay, so if I ask you for the the cosine of 225, what would you tell me? You would tell me that x value, negative radical 2 over 2. Okay, these just so happen to be the same. That doesn't always happen. Okay, the sine is your y value, negative radical 2 over 2. Oh, I got behind. Okay, there we go. So we have 20 negative radical 2 over 2, negative radical 2 over 2. Can anybody already going to see what's going to happen when we distribute? Anybody already see it? What it's going to simplify to? I'll write this stuff just in case. Okay. If I distribute my 20, I get negative 20 radical 2 over 2. What's that going to simplify to? Negative 10, right? Because negative 20 over 2 is negative 10. So this would be negative 10 radical 2. Same thing here. Okay, so that's going to end up being great numbers, but that's okay. Sometimes that's going to happen. But we never, ever, ever put decimals unless our angle is not on the unit circle. Sometimes that'll happen. Okay, I want you to see if you can just get the setup for number 7. Give it a shot. Okay, you should have that. Okay, 12 cosine 150, sine 150. Then we go to our unit circle. Okay, we look for 150, which we just so happen to have. Okay, so our cosine is the negative radical 3 over 2, and our sine is the 1/2. It is so important that you watch for negative signs. If it has a negative sign, make sure that you're careful about writing that there. Okay, we distribute our 12. Okay, and then you can simplify. Okay, and number 8, it's going to be a little bit different. So let's dive into number 8 here. Go ahead and write your component form. Okay, do you see 340 on the unit circle? No. So here's how we do that. Go ahead and grab your calculator. Okay, and we're going to do cosine of 3. Ooh, sorry, let's make sure we're all in the right mode. I'm not in the right mode. Okay, go to mode, over, make sure degree is highlighted. Okay, mode, which is right here at the top, make sure degree is highlighted. Okay, make sure that happens first. All right, so we're going to hit cosine. That's not what we want. 340. Okay, and it gives us that. So here, okay, let me make sure my calculator is good. Now, it looks a little weird, okay? That's okay. Think about what was happening on the unit circle. Okay, it was like 1/2 square root of 3 over 2, which if we do square root of 3, I don't remember the exact number. Square root of 3 divided by 2 is like 0.866. Okay, so it's normal to get these numbers. That's okay. Okay, so when you put it in, you're going to get decimals here, but we're going to go ahead and we're going to distribute first. And then we're going to get our decimals. So you're going to put in 30 times the cosine of 340 and 30 times the sine of 340. Okay, so I'm getting 28. We'll just round it to, I'm sorry, 1 decimal place. So we'll say 28.2 for our cosine. And we'll say negative 10.3 for our sine. Okay, now it's not as nice to look at when we have decimals, but that's going to happen. Okay, not everything's going to be on the unit circle. Okay, so that would be our component form. Not as nice, but that's okay. We're going to end there today. We're going to finish those notes tomorrow. So bring those back. Make sure you don't lose that unit circle, okay? If you do, you can use online, but you want to make sure that you have one for any quizzes or anything that we take.